You can use the NVIDIA DDS texture tools for Adobe Photoshop to generate normal maps from textures. Take your image in Photoshop, such as this wall here, and select File, Save As, and then choose DDS NVIDIA Texture Tools Exporter. Once you've seen the plugin, click on Image Type and select Normal Map Tangent Space. See the tooltips for more details. Now let's see how to modify the settings. First, select how you want to generate the displacement map. Average RGB is the default. You can also use the red, green, or blue channel of the image as a displacement map. Or if you have an image with transparency, you can use the alpha channel as a displacement map. Then choose how to filter in the displacement map. This tool currently provides 6 different filters with different characteristics. In order from sharpest to smoothest, these are 4-sample, 3x3, a Pruitt kernel, DUDV, a 3x3 Sobel kernel, 5x5, 7x7, and 9x9. You can scale the intensity of the normal map using the scale slider. Additionally, you can flatten out low areas of the displacement map using the Min-Z slider. If the texture is a repeating texture, check the wrap box. You can use the invert X and invert Y checkboxes to flip in the directions of your normals. This can be used to adjust for how different engines and APIs read textures. It also has a few options for outputting normal maps with transparency. I can leave the alpha channel as is, make it fully opaque, or set it in the displacement map. This is useful for looking at the displacement map the normal map is using. If you export with this enabled, then this will probably be one of the few times you'll want to turn pre-multiplied alpha blending off, since the alpha channel no longer represents transparency. Finally, you can get slope maps instead of normal maps by turning the normalize option off, which can be useful for post-processing. It's also worth noting that Photoshop now has normal map generation built in, which can also be useful. For compression formats, I like to use formats with modes for normal maps, such as BC5, which saves the X and Y channels of the image. Some engines also use BC3N, which moves the red channel to the alpha channel, and then compresses the color and alpha channels each with BC1. Here I can visualize the X and Y channels separately. Once you're happy with your compressed normal map, click Save. Thanks for watching.